Welcome to Teja Statistics. In this class, we are going to learn about the variations in the SQC. Okay, while considering the variation, first variation is the assignable variation. A variation which is easily identified and controlled is known as assignable variation. So, in calculating the SQC mean chart and range chart and standard deviation chart, okay, so we may use these variations. A variation which is easily identified and controlled is known as assignable variation. Okay, so we can see the examples like length of the product and average, like that. Okay, next coming to the random variation, changes in the quality of the product, unexpected or uncontrolled factors. So they are like assignable, or sorry, they are random variations like wars, earthquakes, strikes, etc. are known as random variation. These two factors may affect our statistical quality control data. Okay, coming to the next point, the very important, the control chart or control limits. So for this, the WA is given this procedure. Okay, a two-dimensional graph is used to identify the assignable variation in manufacturing of a product is known as control chart or control limits. It is a powerful technique used to control and improve the quality of the product. It was given by W. Shewhart in Bell Laboratories in 1920. A typical control chart consisting of three horizontal lines, namely UCL, CL, LCL. What is UCL stands for? Upper control limit. CL stands for central line or control limit. LCL stands for lower control limit. Construct a 2D graph by taking the sample numbers on x-axis and quality on the product y-axis. Okay, if you see, this is our the uh, sample numbers on x-axis and the quality on y-axis, the 2D graph we are considering, and the UCL, LCL, CL values will be there. Okay, if all the sample points lies between UCL and LCL, then the production is said to be under control. There is no presence of assignable variable. Okay, if any point falls outside of the UCL and LCL, then the product is said to be out of control. That is, there is a presence of assignable variation. Generally, the UCL, LCL, CL are represented by high quality, low quality, and medium quality, respectively. Next, types of control limits or charts. So, depending on the measurement of quality of manufacturing product, the control charts are divided into two types. First one, control charts for variables, control charts for attributes. Okay, the control charts for variables. Okay, quality of the product is measurable like width, length, height, etc. In this case, we use the control charts for variables. They are mean chart, range chart, standard deviation chart. Okay, so mean chart is denoted by X bar, range chart is R, and standard deviation chart is sigma. Okay, first, next, the control charts for attributes. These are the control charts used to measure the quality of the product, like taste, smell. Okay, the attributes, we can say that. Okay, they are P, NP. Okay, uh, or D chart and C chart and U chart. Okay, next, just see the 3 sigma limits, the basic control limits or basic control charts. Okay, uh, the complete information of control charts depends on construction of horizontal lines like UCL, LCL and CL. They are constructed by considering the following. Okay, let x be a random variable denotes the quality of the product. In case 1, x follows normal distribution with mu comma sigma square. Expected value of xi is equals to mu and variance of xi is equals to sigma square. The standard normal variate z equals to x minus mu divided by sigma. By the properties of normal distribution, we have the probability is having, that is minus 1 less than or equals to z less than or equals to plus 1. So which we can do with the help of the symmetric property of the normal distribution or standard normal variate. So p of minus 1 less than or equals to z less than or equals to 0 plus p of 0 less than or equals to z less than or equals to 1. So this will become the 2 into probability of 0 less than or equals to z less than or equals to 1, which is our standard normal table. The table value is 0.343. So if you multiply with 2, then you will get 0.68 6 of like that. Okay, and the probability of minus 2 less than or equals to z less than or equals to plus 2. Similarly here you have to consider in the 2 steps again, then multiplying with the 2, the probability of 0 less than or equals to z less than or equals to 2 value is 0.4772, that is 0.9544 you got. Similarly for the 3, so here you got 0.99. So if x is always lies between, thus that mu plus 3 sigma and mu minus 3 sigma, the quality of the product lies between the mu minus 3 sigma and mu plus 3 sigma. Okay, the control units or the control limits are given by, okay, the central line mu plus 3 sigma, which is denoted by expected value of xi plus 3 into standard deviation of xi. Next, LCL mu minus 3 sigma, expected value of xi minus 3 into standard deviation of xi. And the central line mu equals to, okay, expected value of xi. Next, coming to the mean chart. What is a mean chart? Okay, let us consider, okay, a population of manufacturing products in which the quality of the product is measurable. Let the population of size be the capital N divided into k groups. The sample with the equal sizes of small n. Here the sample we are considering with equal sizes, that is small n. Okay, so here you can see the observations: sample number 1, sample number 2, sample number 3 and so on up to sample number k. And the observations x11, x12, these are the locations. The total of first, second, okay, total t1 dot, t2 dot and ti and so on like that. And t1 divided by n, that is mean of the first row, and t2 divided by n, that is mean of second row. Like that we got xi bar. Okay, and here also we calculated the range. the maximum value of this row and the minimum value of this row again. Okay, next k. Similarly, for all the k values we are calculating. Next, the notations plays very important role. Xij is equals to, okay, the quality of the jth product in the ith sample. Ti, the total of ith group. Ti is equals to summation I runs from 1 to summation j runs from 1 to n. So similarly, the total and the mean of the ith group, Ti divided by n. Like that we have some uh, the range calculations also. Okay, Ri is equals to maximum of xij minus minimum of xij, where R bar is mean of all ranges here. Okay, let's derive the 3 sigma control limits for uh, mean chart. Okay, so x follows normal distribution with mu comma sigma square. Expected value of xi is equals to mu and variance of xi is equals to sigma square. So the control limits are UCL, that is expected value of x bar plus 3 into standard deviation of x bar. You can see the expected value of x bar is equals to expectation of 1 divided by capital N or small n summation xi. So this summation 1 divided by n will it come out from the expectation, and summation will be remain same. Expected value of xi, that is mu. Okay, similarly variance of xi bar also we calculated. So any constant of variance will come with the square. Okay, 1 divided by n square summation variance of xi. So 1 divided by n square into n into sigma square. After calculating the variance of xi bar, we got sigma square divided by n, and the standard deviation of x bar, that is sigma by root n. Okay, just substitute that values in a UCL formula. What is upper control limit? Expected value of x bar plus 3 into standard error or standard deviation of x bar, that is mu plus 3 into sigma divided by under root of n. So this will brings you the constant value 3 divided by root n as a. So UCL will become mu plus a into sigma, and similarly LCL will become mu minus a sigma. CL will become mu. Case 1, if mu and sigma are unknown, how we are going to replace it? That is mu equals to mu1. Here where the case 1 we are saying it is a known value. Mu equals to mu dash and sigma equals to sigma dash. Therefore the control limits are UCL is equals to mu1 dash plus a into sigma 1 dash. Similarly LCL and CL. Case 2, if mu and sigma are not known, then they are replaced by its unbiased estimators. Okay, expected value of x bar is equals to expected value of double summation xij. So if you remove the double summation, you will put the value of n. Expected value of xij is equals to mu again. So here x bar is an unbiased estimator for mu. So next r bar also we are calculating. See the calculations here. Here a got v value. Here 3 divided by root n, and d2 is a constant r bar. So the 3 sigma limits for range also we calculated here. Okay, expected value of r bar is equals to d2 into sigma, and d2 by r bar divided by d2 is an unbiased estimator for sigma. So just replace that. Therefore the control limits are given by, for the mean chart, is equals to x bar plus, okay, UCL, no, so we have to write the plus x bar plus a into r bar divided by d2. In place of sigma we are writing that one. So r bar divided by 2 is equals to a2. Next, like this we have LCL also and we have CL also. From the above control limits, construct by mean chart and taking the sample numbers on x-axis and quality on y-axis. Like this you have to prepare. The conclusion here you have to make, that is, if all the sample points lies between UCL and LCL, then the production process is said to be under control. Otherwise, it is said to be out of control. Okay, this is the next explanation for the range chart. We will continue in the next session. Okay, up to this, the mean chart is completed. Thank you.